All right, for this example, we're given this function with two independent variables, and we're asked to find the values of the partial derivatives with respect to x and y at the point 4, -5. All right, so let's start by taking the partial derivative of f with respect to x. So when we take the partial derivative, we're going to differentiate this just as we normally would with respect to x. And then when we come across a y, we're just going to consider that to be a constant. The derivative of x squared is just going to be 2x plus, now remember that y is a constant, so 3y times x, the derivative is just going to be 3y. And then if y is a constant here, the derivative of that is just 0. And this is a constant, so the derivative of that is 0 as well. So the partial derivative with respect to x is 2x plus 3y. Now let's evaluate that. So we have delta f, delta x, evaluated at this point 4, -5. So let's plug in 4 for x and -5 for y. And that's going to be equal to -7. All right. Now let's do the partial derivative of f with respect to y. So now we're differentiating with respect to y, and we're considering x to be a constant. So if this is a constant, that the derivative of that is 0. 3x is our constant here, and times y, the derivative of that is 3x. And then the derivative of y is just going to be 1. And the derivative of -1 is 0. So here's our partial derivative with respect to y. It's going to be 3x plus 1. And let's now evaluate that at the point 4, -5. So this is going to be 3 times 4 plus 1, which is equal to 13.